Hi everyone, I'm here to do LeetCode problem number 203, remove linked list elements. Let's get started. So given the head of a linked list and an integer val, remove all the nodes of the linked list that has node.val equals val and return the new head. This is an easy linked list problem. As you can see, the value that we're given a linked list and the value is 6. So we want to cut out all the 6s from the linked list. And that's basically it. In this example, there's no linked list and we get no linked list back. And in this situation, we have a linked list of all 7s and the value that we're targeting is also 7. So we also return the empty list back. This is not a hard problem, and you can do this problem either iteratively or recursively. But I'm going to try the iterative solution right here. So we have constraints. The constraints always let us take a look at the edge cases. Understand the edge cases, that's what I mean. The number of nodes in the list is in the range 0 to 104, which not 104, 10 to the 4th. The number of nodes in the list is in the range from 0 to 10 to the 4th. So that's good to know, in that the linked list can get very large as 10 to the 4th. And we also know that let me take a look at what this is. The node.1 is less than or equal to node.val, which is less than or equal to 50. And val is between. We also know that 0 is less than or equal to val, which is less than or equal to 50. Let me think for a minute what's going on right here. What's the difference between node.val versus val? That is not clear to me right now. So we have okay. Node.val is the value that we can store within the linked list in the node. The value can range from 1 to 50, and the value that we're searching for could be anything from 0 to 50. Okay, so the topic is, of course, a linked list. That's what the topic is. But if you don't believe me, we can check also. This is a linked list or recursion problem. Okay, so before we design the algorithm, I was told that I should explain my thinking first and explain why we do something first before we jump right into the algorithm. And the way that you think about this is that there are two cases that you need to be mindful of. And this is illustrated first right here. Let's say the value that we want to delete is 7, and we have that value at the head of the linked list, not just one node with that value of 7, but multiple nodes with the value of 7. In this situation, this is just a pure deletion at the head, and we need to do that potentially multiple times, right? That's one scenario. And the other scenario is that the value that we're trying to delete is in the middle of the list or at the end of the list, but we're going to treat them the same. And so basically, once we encounter such a node, we would want to delete and skip over this node. And to delete a linked list, you have to find the node that is right before it. You have to mark this node and have the pointer point right here, so that you can move the pointer over to the and skip over the node that we're trying to delete. Okay, so this is not going to be hard. So let's take a look at the algorithm. Treat the case where the node at the head of the list has node.val equals val. Keep in mind that multiple nodes can start at the beginning of the linked list where the condition is true. Just do something right here. This should be like a subpoint actually. Okay. Then the next section is define a while loop that will loop through the linked list. Define condition that will check if the next node has node.val equals val, right? Because we have to, if we want to delete this node, we have to mark the previous one and mark the previous node and tell the algorithm that, hey, the next node in the linked list is the one that we want to skip over. If the condition is true, then delete the next node. Else increase the cursor. Okay, so this is the algorithm. Let's do it. So we have while head dot next equals not equal to none, and head dot val equals val. Head equals head dot next. Cur equals head. While cur is not equal, cur dot next not equal to none. Cur does not equal none, and cur next does not equal none. If cur dot next dot val equals val, cur dot next equals cur dot next dot next, else you do cur equals cur dot next, and we return the head. While head dot next does not equal none, I think it's just actually head. Let me see. Let me see what the error is. While head.next does not equal none, and head.val equals val. Hang on, give me 1 second. Okay, so this is correct, and the syntax error is right here. I forgot an equal sign. If cur.next, okay, I forgot another equal sign. Okay, so this works. And so it works, right? I'm going to type it one more time just to make sure I get it, because that implementation was a little shaky. While head does not equal none, and head dot val equals val, head equals head dot next, and then we have cur equals head, while cur does not equal none, and cur dot next does not equal none. If cur dot next dot val equals val, then what do? You do a cur dot next equals cur dot next, and else you do cur dot next, and then of course you return head. Time limit exceeded. While head does not equal none, and head.val equals val, head equals head, cur equals head, while cur does not equal none, and cur.next, if cur.next.val equals val, cur.next equals cur, I forgot right here, equals cur equals cur.next. There we go. Okay, and so the time complexity is O of n, because you're looping through the linked list one time, and the space complexity is O of 1. We're not defining any new, we're not allocating any new space. Okay, so there's this problem. It's an easy one, but it's always good practice. Thank you, everyone, and I'll see you at the next one.